What's up guys, welcome to my channel. In this video I'll be going over how the symbols for Boolean logic gates are used and what they represent, how you can represent a diagram from an expression and vice versa. I'll also teach you guys how to use an online simulator to represent expressions. So without further ado, let's get started. To keep things simple, I'll show you guys how this works with only two bits A and B. Each bit A and B can either have the value 0 or 1, since it's represented in binary. If the bit is 0, then it means that the value is false. If it is 1, then it'll mean that it's true. So just keep that in mind when we are doing the expressions. So when we're looking at Boolean expressions, we are looking at these three main symbols: the AND symbol, the OR symbol, and the NOT symbol. These are the main three expressions that we use when we are expressing logic gates. So say we want to represent A and B. Now we can first put A and B on the sides, and then we can put every single combination that A and B can represent. So A can be 0 and B can be 0. A can be 0 and B can be 1. A can be 1, B can be 0, and A can be 1, and B can be 1. Now we look at the outputs. So when both A and B are 0, which would mean false and false, you would not get a true value from that. You would get a 0. Now, if A is false and B is true, which is what this represents, you would still get a 0 because both of them are not true. Same thing with the next one. And when we jump over here, we see that both A and B are true. That means that your output will be true. So the only time in this case when you have an output of true is when both of them are true. And that's what you want, because that's what this symbol represents. For the next one, say you want to represent A or B. Now we look at the chart. So A or B. So only one of them have to be true in order for your output to be true. So in this case, we have false and false. Since neither of them are true, your output will be 0. Now you have this one. When A is 0, A is false, and B is true. So one or the other is true, so your output will be true. In this case, A is true, and technically when you're looking at this, if the first one is true, then you don't have to look at the second one, but it's good to anyway, but your output will be true in this case. Now you have both A and B are true. It doesn't matter if both are true unless it's an exclusive OR, which we'll get to in another time. But since one or the other is true, then you do true. Alright guys, so next up is NOT, the expression. So NOT just takes one bit and it sees what value it is. In this case, it's 0. So NOT 0 would be 1. Because it is just the opposite and you only have two binary bits. The next one, when A is 1, you want to see what not A is, and that would just be 0. Let's combine all these together and see what outputs we get for that. So this expression, not A or A and B. So we first look at the main separator between the two, and it's this OR right here. So if we can just look at the first one, and if not A is true, then we can automatically put out the outputs that the output is true. If it's not true, we can still look at the second part of the equation, of the expression, and see if that is true. If that is true, then our output will also be true. Otherwise, our output will be false. So let's go through these. So we're looking at A first, and not A is true, so we can actually say that our output is true. let's look at our second one. Since A is 0 and not A will be true, we can actually say that that is also true. Now for these. So we look at A, and A is true. Not A will be 0. So we actually have to go and look at the second one, at the second expression, and see if this expression is true. So A and B. That means A and B both have to be true. A and B are not both true, so our output will be 0 because this part of the first part of the expression is false and the second part of the expression is false. Now we can look at our last one. So not A is 0 because A is 1. So we actually have to look at the second one now. Now we look at A and B. Now A and B are both 1. They are both true. So this part of the expression is true. That means our output will be 1. Next up, I'll show you guys how to represent this in a logic gate simulator. So I'll add the link to this in my descriptions below, and you guys can test this out for yourself. But I want to show you guys how we can represent this expression in a Boolean logic gate. So let me explain to you what these different symbols are. So this is a NOT gate. This will do the same thing as this NOT symbol right here. And then this AND gate will do the same thing as this symbol right here, as the ampersand. And then we also have the OR symbol. And the OR symbol will do the same thing as this symbol right here. Okay, so first we can look at how many variables we have, how many bits we have that we are representing. And we have 2 bits, A and B. So we can put in a positive input for A, and we can put in a positive input for B. And we just add these switches in so that way we can turn them on and off to represent zeros and ones. So for the first one, for the first side, we are representing not A. Since this is our A, we can connect this not symbol, up to A. And I'm just going to add a wire here so I can attach that. And this will actually go, well actually let me show you how to do this part. So the A and B will be represented by this symbol right here. A and B, so you want A and B going into the AND symbol. So we can connect a wire for B. B will be connected here, and so will A. Now, the main expression separating the output is the OR symbol. So the OR symbol will be attached next. We can just do that there. That's fine. And then at the end, we put in an LED output that's connected to the end to show us what our outputs will be. So if we click run, now A is false and B is false. That means when they are false, that means that there's no current going through them. So when they are both false, the output is true, and that's why it's red. It's lighting up. So let's see when A is false. So A is false, and B is true. So when B is true, we connect the circuit, there's nothing going through, and we still see that there is a positive output, or it's true. Now let's look at when A is true. So we connect true, and B is false. There's no output. The LED turns off. That's why we have a 0 here. The next one is when they are both true. We can click on both of them are true, and we can see that our table is correct and our logic gate is correct according to our outputs. Here's a logic gate that represents three variables, A, B, and C. Now, how do we create an expression from this? So, what I like to do is I like to start from that output backwards. So, here is our entire expression that we'll use, and I just like to put it in parentheses, that way I can keep track of where I'm going. So that's the output, and then it's going to be split two sides going from here, and it's separated using an AND. So what I like to do, since it's separated into two, and it's using an AND, so I like to put an AND there, and so that's separated into two. Now let's look at the top side. So we'll go this way. So over here, there's another AND. So on this side, there's a separation of two, and then we have an AND and another separation of two. Now let's go to the top part. So when you follow this, you see that there's a NOT, and it's followed by an A. So in the first one, we can put the symbol NOT, and we can put the variable A, bit A. And then in the second part of the parentheses, we follow this one, and that is just B. There's no other symbol that comes along there, so you can just put B. Now, this part is the second part of that main and you can follow that, and there's an OR. So we could go to the top part of the or actually, we have to do this first. So on the top side, and then there's an OR, and then on the bottom side. So on this top side, we follow just B. So there's nothing happening with B. And then on the bottom side, we just follow C. Therefore, our main expression will be not A and B and B or C, and you have that as an AND. So this would be the correct expression for this logic gate. Alright guys, so let's look at this expression and this logic gate in a table form. So I'll just hit play right here, and when all of them are false, when none of them have a positive output going through, you see that the output is not lighting up, so this will be 0. For the next one, it's false, false, true, so you have false, false, and you can click true, and you see that there's no output going through here, so there would be no output. And you can actually follow along. So this is an and since both of them are not true, this will not work. For the next one, it's 0, 1, and 0, which is false, true, false, false, true, false. And you can see that there's flow going through both of them, so it will light up. And I'll just go through these really quickly just so you can follow along and see what I'm doing. So whenever it's true, you just toggle these buttons. And you can just follow through all the way. 0, 1, 0, 1. And then 1, 1, 0. And lastly, I've created this Boolean logic gate for you guys to follow through and get your own expression from it. And you guys can actually follow this table, which corresponds to all the combinations that you can have from having 1, 2, 3, 4, and 5 positive inputs. You guys can follow through and try it out yourself. I'll post the links to both of these in the description just so you guys can do it on your own. But I really hope you guys enjoyed this video and leave a thumbs up. Thank you.